Okay, solve this. Around. So all of you can read this question? Great. You know how to do this? If you don't know, I will tell you how to do this. You have to be frank enough to say, sir, I don't know how to do this. And don't simply think around. You should very confidently do this. So you have one rod. You have one rod which is along the y direction, and you have another rod which is along the x direction. Correct? So, and both of them are intersecting at the origin. Okay. What is the moment of inertia along the line x is equal to y? That means along this axis. Can you do this or no?
Yes, sir.
Okay. If you are through with the answer, you should tell me.
Option B.
Option B. I got only one person responding. Hello, you cannot take so much time. This problem can be solved orally by inspection. Understand? By orally by inspection, you can do this. You don't need that. So that means, see, please be frank and say, yes, sir, we don't know. Don't do any hanky-panky methods. Okay? See, I have taken very simple numericals because it's a revision program. I know most of you would not have taken up this chapter of rotational motion or rigid body dynamics. So I have taken very simple questions so that from grassroots I am developing it for the benefit of all. But yes, I have requested everybody to go through NCERT book, mark the concepts and come prepared. That minimum work if you have done, my classes will be useful. Okay, otherwise no. Now let me tell you how to handle this. Anybody else with the answer?
Yes, sir. Done.
What?
Option B.
Hey, subsora matado. Option?
Option C.
You got option C. Okay, fine. Let me see what is the option. Now, if you take the moment of, see, this is xy and you have got the axis z axis, correct? You have got the z axis here. Z axis will be what? Perpendicular to this board, correct? Hello? So Z axis is perpendicular to the board. Now the moment of inertia of the rod 1 about the center. So what is the moment of inertia of rod 1 about the center along the Z axis? So I1 along the Z axis is what? M L square by 12, correct?
Yes.
Then similarly, moment of inertia of the second rod, okay, along the Z axis at the same point will be what? I2Z, correct?
Yes.
That will also be seen, right? M L square by 12, correct now?
Sure.
So what is the total momentum of 1 and 2 along the Z axis? It will be this plus this, so it will be ml square by 6, correct?
Yes.
So now see, bit of imagination is necessary. So this IZX is along the axis which is perpendicular to this board and passing through this O, correct?
Yes, sir.
Now what you do, you see, so now you have got a vector which is, sorry, not vector, the moment of inertia axis is perpendicular to this board and passing through O, okay?
Yes, sir.
Now convert that into perpendicular axis. That is, you now have, take like this. So this is x dash, okay, x dash along the axis, x dash, x double dash, and y dash, y dash, y double dash. So now this moment of inertia, you split it along the two axes. That is, so here you will get it as I x x1 plus I x I y y2. Correct? So, but these two will be equal, isn't it? So this will be I x x1, I x dash x double dash, x dash x double dash. So you do have to divide it. So you will get here m l square by 12. Okay, so option C is the right option. Who said that you got this option C?
Adil.
Adil. Did you do the same method?
Yes, I did.
Tell me what method you did fast.
I considered one half of one particular answer. I took a small into element and
You integrated it, yes.
Yes.
Okay, so fine. Then let me see. Okay, see others, Mr. Arun, you got it wrong. Okay, fine. Now let me do it like this. So now assume that you have got a rod. You have got a rod of mass m and length l. Okay. Now I want you to find the, so this is a y dash. So I want you to find the moment of inertia of this rod, okay, and this is passing through the center of the rod, okay, this is passing through the center of the rod, okay, this is center of the rod. So I want you to find the moment of inertia along the axis y dash, which is making an angle theta. What is the moment of inertia of this rod ML along the axis y dash, and y dash is making an angle theta. I hope all of you understood the problem. Can you do it or no? You tell me. Now don't do any hand. How will you do it? Come on, tell me. Come on, discuss with me. You want some training from me or no? Don't simply go on doing something to prove a point or something. Sit here and learn. Okay, so tell me, what is your strategy to handle this problem?
At a distance x from that center set, we take a small element dx, and we can find the mass of that element dx, and we'll also find the perpendicular distance from the axis to that dx.
So what you are telling, I will just mark it here. So you have taken this small element here. At okay, now you will take this axis as say some axis P dash. Okay, and this element will be DM element. Okay, and it is at some distance P from here. Correct?
Yes.
This is precisely you told, and then you are going to take the perpendicular distance from here. Correct?
Yes, sir.
Huh?
Yes, sir.
And this perpendicular distance will be what?
That will be P sin theta.
P sin theta. Excellent. P sin theta. Okay. This is P sin theta. And then now you will find the moment of inertia of this. The moment of inertia of that will be dm into P sin theta square. Correct? And then you are going to integrate this. Okay, you are going to integrate this for p going from minus this point. So this point you can take it as what? Minus L by 2 to plus L by 2. Correct? Minus L by 2 to plus L by 2, and substitute for dm. So dm will be what? The total mass is m, length is L. So you will get it as m by L into dx dp. So m by L will come out. Integration minus L by 2 to plus L by 2. So instead of dm, we are going to write it as dp. So you will get p dp. Okay, and in this case sin theta is constant, so sin square theta is p square, sorry, p square dp, and sin square theta is constant here, so you are going to get sin square theta out here. Okay, and then you are going to perform the integration of this. So you are going to get here m p cube by m p cube sin square theta by L. Okay, and the limits of integration is minus L by 2 to plus L by 2. So you are going to get what here? M L square sin square theta by 12. Sorry, I have not written here. P cube by 3 we should write here.
Yes, sir, correct.
ml square sin square theta by 3. We are going to get this. Correct now? Mr. Adil, did you do this? Huh? Mr. Adil, did you do this like this?
By 12, sir.
How will you get 12?
Apply limits.
Apply limits. Okay, L by 2. I have taken L by 2. Sorry, I have taken L by 2. I'm sorry, L by 2. You'll get apply limits. Mr. Adil, did you do like this?
Yes, sir.
Who told you to do like this? Who told you to, don't worry, I'm just asking you, who told you to do like this? Or what idea made you to think like this? You have solved some problem similar to this?
Sir, yesterday in class we did no, sir, that 60-degree bend. Was there we first tried, no, sir?
So somewhere I tried that and you have taken the hint. Okay, now for others I am telling you, okay, see, again I am telling you, the theory for this is dm, okay, r square. So, and with this only we have developed everything, mr square by 2, etc., etc. So this theory what is given in NCERT is sufficient even to solve this problem. And I am sure in your class, in the college, you have solved sums which are 10 times or 20 times difficult than this, using moment of inertia, etc. So again I am reminding you, solving big problems, hundreds of problems, what is that you have gained? You introspect yourself and see. Okay, you have done hard work, you are good students, I am not denying that. You are sincere, honest, everything. But the way you are using your time, the way you are getting learning science is wrong. That is why you see, even at this stage, you found it difficult. So therefore, my dear students, I am telling you, you concentrate on learning. And with every numerical will solve, you aram se think, okay, this is what. After my class, just sit and look at those numericals. And see if you can do it better than that. Just 5 minutes. Okay, see, unless your brain works, it will not work. This was a simple problem I expected everybody in this class to do, and unfortunately only one student did it. Okay, anyways, there are 2 ways by which you can do this. I have shown you both the ways. Okay? Hello?
Yes, sir.
Only you are telling yes. I wanted somebody else to say yes because all this lecture was for somebody else, not for you. But if you don't know some theory, you ask, I will help you. See, this RBD I have taught for 60 sessions of 1.5 hours each. Understand? 60 sessions of 1 hour, that means 90 hours. So if somebody is asking me, sir, do some brush up, how many hours can I do brush up? Whole of October, November, if I brush up also, it will not get completed. Okay, so all that I am telling you is, go through NCERT book, underline the concepts and just come to the class, or at least you send me a mail. Or whatever you are not understood, you just say these are the sentences I didn't follow. I told you I will teach the theory and go forward. But that effort also you are not putting. I don't know how to help you. Anyways, God save you. I hope all of you can see this problem. Right, please solve this problem. This is problem number 23. Study this problem carefully and do this. Try to understand, make some drawing. Aram se. Have you made the drawing, initial drawing?
Yes.
So what is the initial drawing? They are told only rigid body, they are not told anything else. So you can even take the simplest of the rigid bodies here, that is a rod. Correct?
Yes.
The simplest of the rigid body, you take a rod. Okay? And well, you are free to assume that its length is L. Okay? And its mass is M. You just make some assumption. Okay, then they are told it is hinged at X. I think all of you know what is hinge, no? Your window has got a hinge so that it can do like this about that point. So you can draw a hinge here, right? That means this rod can rotate about this hinge. Got it now? This can rotate this side about this side, and this side also it can do this. This is a hinge. I suppose all of you got this. Okay, then as we have told, this point will be x is equal to 0 and this point will be some x. Okay? And they are told a rigid body can be hinged about any point on x-axis when it is hinged such that the hinge is at x and the moment of inertia. And the moment of inertia means, now if you take this as the x, so if you take mark the direction as x, okay, and then you take this as y, right, and then of course you will take this as z axis, right? Okay, so now if you take this as x axis here for this, then y-axis will be up. So therefore, the moment of inertia we are going to consider it is along the z-axis. Okay, and this is what they have given. What they have given? This is equal to x square minus 2x plus 19. Okay, now the x coordinate of the center of mass. So what are they asking us? They are asking us the x coordinate of this is what they are asking. So just write the problem at least, and think what is to be done. And this iz they have given it as I in the particular problem. In this problem they have given iz at that point O. So if you take this point O, iz at O, they have told it is I. They are asking the x. Come on, it's a very nice problem. All of you are very intelligent students. Come on, use it and do it. Hi.
Sir, what is the relation between moment of inertia and center of mass?
See, your thinking is right and you know the answer. You know the answer, right? See, you just recollect NCERT book. In the chapter inertia, moment of inertia, axis of inertia, everything but good. Where have you come across the x-com in the entire chapter, the center of mass? Under some section in this particular chapter, RBD, you have come across x-com. Where did you come across? Where? Which section? If you have studied NCERT properly and you have done at least what I have told, then you will definitely tell. Where have you come across? Anybody else? In this entire chapter, where is the mention of the center of mass? Tell me, if you have sincerely read this chapter from NCERT, you have answered for this question. The answer is there in NCERT book. Nobody is able to tell? Aniket?
The radius of gyration.
Radius of gyration, we have got center of mass. Okay. Other than that?
Sir, when we were doing collisions.
Hey, in RBD.
Yeah, please.
But again, in this chapter in NCERT book, when you are studying this inertia, moment of inertia, where under what section have you come across the center of mass? If I tell you the answer, then you will say, oh, like that. See, this is what this generation of students are. You don't do the right thing, and even if somebody advises you properly, you don't want to listen. You don't have that this one, this fellow is also useless fellow, that fellow is also useless fellow, I am the right person. Hello, have you not studied parallel axis theorem? Hello? Have you not studied parallel axis theorem?
Yes, sir.
So in parallel axis theorem, what is that you have studied?
That when we consider an axis and moment of inertia over that axis, sir, and when we shift it by a certain distance, then when we shift that axis parallelly by a certain distance x, then its moment of inertia is mx square times more that of the initial moment of inertia.
Initial moment of inertia, what is that?
Moment of inertia about the first axis.
First axis.
When you take two axes, sir, and you number them 1 and 2.
ನೋಡು ಇದ ತೋರಿಸ್ತದ ನೀನು ಒಂದು ಚೂರು ಪುಸ್ತಕ ತೆಗೆದು ಓದಿಲ್ಲ ಇರ್ಲಿ ನೀ ಇದ್ದಿದ್ರೊಳಗೆ ನೀ ಗುಡ್ ಬಾಯ್ ಅದಿ ನಾವು ಒಪ್ಕೋತೇನೆ ನೋಡು ಉಳಿದವ್ರು ಬಾಯ ತೆಗೆಯಕ್ಕೆ ರೆಡಿ. Anybody else? Parallel axis theorem?
We have to consider the axis about the center of mass.
ಹೌದಿಲ್ಲ?
Yes.
If you know the moment of inertia about the axis passing through the center of mass of the body, then the moment of inertia parallel to that axis, shifted by a distance d, will be what? IC plus md square. Correct, no?
Sir. Yes.
That is what you have studied, no?
Sir.
Then nobody is answering, and you want to sit here and get trained for mains, NEET, advanced. You don't want to do any effort. That parallel axis theorem itself you have forgotten. Nodi, ನೀವ ನೋಡಿ ಹೆಂಗದಿರಿ ನೋಡ್ರಿ ನೀವು, and whatever marks you are getting, it is a reflection of this particular thing. You are going to the examination hall saying, I know all theory, I have solved so many problems and all, but the truth is this. At least now you open your eyes. Using that theorem, you can solve this problem. I hope everybody got the theorem here.
Yes.
Now use that theorem and solve this problem. ನೋಡಿ, ನಿಮ್ದು ಥಿಯರಿ NCERT ಬುಕ್ ಥಿಯರಿನ ಅದನ್ನ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಹೆಂಗ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಯಾರ ನೋಡ್ರಿ. This is simply the theory in numerical. The parallel axis theorem is used here. That's all. So if you have this body, if this is the center of mass, this center of mass, and if you have an axis passing through the center of mass, the moment of inertia about this axis, supposing is IC, then you take some other axis which is parallel to this axis. Okay, parallel to this axis. The moment of inertia about this axis will be, if you take this distance as t and the mass of this is m, then I is equal to moment of inertia passing through the center of mass plus m d square. This is parallel axis theorem, correct? Mr. Abhinav, not any axis. Parallel axis theorem is, and then you told any, shall I show you a recording?
Yes.
You never use the word passing through the center of mass. So this plus this. I hope all of you know this. Anushris, Aditis, Prabhus, Saurabhs, Namans. Okay, did you get it?
Sir, what is math? Just for this problem, sir.
Hey, ಇದು ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು. ಇದು ಗೊತ್ತಾಯ್ತಿಲ್ಲ ನಿನಗೆ?
Yes, sir.
ಮುಗೀತು. ಈ ಪ್ರಾಬ್ಲಮ್ ಈ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡು. ನೀನು ಬರ್ತಾಯ್ತು? ಅದಿಲ್ಲಪ್ಪ ಮಾಡ.
Sir.
Yes, Aniket.
Sir, here, can we say that moment of inertia about center of mass will be minimum?
Minimum? Who is asking you to say minimum and maximum?
No, so then we can simply differentiate it and equal to.
ಹಂಗೆಲ್ಲ ಇಲ್ಲಪ್ಪ ಇದು. It is not a free rod. It is not a free rod. Okay? No, don't get into those complications. See, simply you see here, they are asking you what is the, see now I told you, I gave you a hint, use the parallel axis theorem, correct? Now use that. How will you use it? Now assume that this is the center of mass and draw an axis. This you call it as, see, not here, I am sorry. Okay, now draw the axis passing through this point. Let this be the center of mass. Hello, got it?
Yes, sir.
So the axis passing through this perpendicular to this board, axis passing through this perpendicular to this board will be what? IZC. Okay, and this perpendicular to the board passing through this point is IZO. Correct?
Yes, yes, sir.
Now what is the relation between this IZO and IZC? So, correct. Now tell. IZC, right, plus the mass of this rod, I told you to take it as m, and this distance, some distance d you take, md square is equal to this, what they have told you, Iz. Correct? So
yes, hinges at x.
hinges at x, so what? Hinges at x.
Then we can, we know that center of mass of that rod will be L by 2.
ಏನು ಬೈಲಿ ನಿಂಗೆ ತಿಳಿವಲ್ತಾಗೈತಿ. ಈಗ ಹಂಗಿದ್ರೆ ಬಂದ್ಬಿಡ್ತೈತಲ್ಲ, ಪಟಾಪಟ್ ಬರ್ಯಾಕ ಬಂದ್ಬಿಡ್ತೈತಲ್ಲ. ಈಗ ಈ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮುಂದುವರ್ಸೋದು, ಈ ತಲೆ ಎಲ್ಲೆಲ್ಲ ಹಾಕ್ಬಿಡಿ. ಈಗ ನೋಡಿ, ಒಂದೊಂದು ಪ್ರಾಬ್ಲಮ್ 20 ನಿಮಿಷ ತಗೋಬೇಡ್ರಿ. ಸೊ ರೈಟ್ ದಿಸ್ Iz is equal to what? So here it is x square minus 2x plus 90. At least the basic equation you have formed. Now you expand this. So this is IZC plus m into what is d? What is d? D will be what? So from here, if it is x is equal to 0, this point becomes xcom, no?
Yes.
Matlab, ಇದು ನೀವು ಹೇಳ್ಬೇಕಾಗಿತ್ತು, minus xcom minus x square. This is equal to x square minus 2x plus 90. So what is your next step? Your next step is just expand it, okay, and equate the coefficients. Expand it and equate the coefficients. So if you expand this, so this is a constant plus m x com square plus m x square minus 2x x com into m, okay, and this will be equal to x square minus 2x plus 90. Equate the coefficients. Equate the coefficients. So here you see, with x square there is only one thing, m, isn't it? The coefficient of x square is m. And what is the coefficient of x? The coefficient of x will be 2x m. Correct? So that is, see here, minus 2x com m into x is equal to minus 2x. Correct now? So you can just cancel out these two. And the second thing is, the coefficient of x square is m, and the coefficient of x square in the right side is 1 into x. Hello? Now you divide one by the other. So this minus 2 will not get knocked off. Okay, and therefore now you get here, you have to equate the coefficients. So what are the coefficients? X com into m is equal to 1, and here what you get here, m is equal to 1. So divide this by this, okay, and divide this by this by this. So you get straight away x com is equal to 1.
We get same answer, sir, even if we differentiate and do it.
I don't know whether you have to differentiate and do it. But see, it is not a free rod. That's what I am trying to tell you. It is not a free rod. Okay. If it was a free rod, then it is different. Of course, when we are writing this, we have not taken the hinge into consideration. In that way, it is fine. In that way, it is fine. So therefore, you are getting the answer. But I was not putting my head in that direction, because sometimes, I have to really think, should I differentiate it or no, depending upon the condition. But yes, now. Okay, everybody understood this solution?
Yes, sir.
Yes, what is your doubt?
So that I of center of mass are IISc. So how can we take that as a constant thing? With that?
For a rod, if I give you a rod, if I give you a rod of length L and mass m, so the center of mass is fixed. If the center of mass is fixed and the mass is fixed, the length is fixed, then the moment of inertia about the center perpendicular to it is also fixed, no? What are the variables there?
Yes.
Okay. Now coming to Aniket's solution. Aniket has done it something different. So now Aniket, when he first told me that the moment of inertia about the center of mass is minimum, how did you know that the center of mass through the moment of inertia through center of mass is minimum, Aniket?
Sir, when compared to any other parallel axis, sir, it should always be less, sir.
Good.
You can apply parallel system.
Excellent, excellent, excellent. I really appreciate. I really appreciate. You are a sincere boy who has studied the chapter, I am sure. Good. So what your abstraction is correct. But when you first suggested that, I was not prepared to use that because this is hinged. This is hinged. But nevertheless, when we have written these equations, we have used that hinge point only for this x. Other than that, we have treated this rod to be a free rod. Correct?
Yes, sir.
Other than that, we have treated this rod to be a free. A free rod. Okay. And Aniket is right in differentiating this. Aniket is right in differentiating it because he has said, well, the moment of inertia about any axis is so and so. So if I differentiate this and equate it to 0, then I should get the minimum. And that's a very, very brilliant thinking. Hats off to you, Aniket. Hats off to you. Wonderful. Great. Okay, see, now this is something which has to evolve in this class. Some out of the box thinking should be there. Do it, so that shows your involvement. Well done, Aniket. Keep it up. Okay, shall I proceed, students?
Yes, sir. Yes, sir.
See, even to say yes, sir, some people are not opening their mouth. God save them.
Done.
Those who have done, you tell your names.
Abhinav done, sir.
Somebody else also said done, but he didn't see, he is afraid to tell his name. ಬಂದ ತಿಂಗಳು ಅನ್ಸರ ಯಾಕೋ ಇವತ್ತು ಅರುಣ್ ಏನು ಹೇಳವಲ್ಲ ಇವತ್ತು ಯಾರು ಬನ್ನಿ ಕೊಟ್ರಪ್ಪ ಅರುಣ್ ಬನ್ನಿ ಕೊಟ್ರೆ ಹೇಳ್ತಾನ this can be orally told, no?
Yes.
Isn't it? So x and z are mutually perpendicular and y-axis is perpendicular to the plane. So whatever is the moment of inertia along y-axis, you should use perpendicular axis theorem. So 40 minus 30 is 10. C should be the option.
Yes.
That's it. Perpendicular axis theorem. Ix plus iy is equal to iz.
No, sir.
In this case, just to confuse you, they are given y-axis perpendicular. That's it.
Yes.
Okay, shall I proceed?
Yes.
ನೋಡ್ರಿ ನಿಮ್ದ ಟೈಮ್ ಉಳಿತದ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ರಿ So you can imagine a wheel is rotating, there is an axis. So this wheel is rotating some omega. So it has to be brought to rest. So you are going to apply the torque to bring it to rest. So where are you going to apply the torque? Okay, you can apply the torque here.
Yes.
At the center. At the center. So the torque you will apply it along the z direction. Okay.
Yes.
That is one thing. Right. So by a constant torque, finally brought to rest. So therefore, what are the things that they are given here? Omega, they are giving it as omega, they are not giving omega, they are giving you F. F is equal to 720 RP per minute. If you divide it, you can 6, how much does 6 12 is 72. And therefore, omega will be 12 into 2 pi, that is 24 pi radians per second. So you can get omega, and they are giving you time t, and t is 8 seconds, and finally it is brought to rest. Therefore, we can assume constant acceleration, and you can get alpha is equal to omega by t, that is 3 radians per second. So with the given data, okay. Now they are telling you torque. So alpha is equal to what? Torque by moment of inertia. Torque by moment of inertia, and moment of inertia also they are given it. Okay, so therefore tau is equal to alpha into alpha is 3 pi into I is 24 by 5. So 5 pi cancels. This will be 72. Okay,
Yes.
units. So we have got 72. Yes, this is good. See, I have taken very simple problems to bring out these concepts. So torque, alpha, equations, etc. If you want to know something more, you can ask, I will explain. Okay, if you give me permission, I will go ahead. Shall I go ahead? You want some explanation here? Nothing? Okay. So get hold of the problem. So rod. So this is hinged at this point. So this is the horizontal. So the mass of this is m and the length is l, and so this is x is equal to 0, this is x is equal to l, and a force is applied, horizontal force F is applied, so at a distance phi l by 2. So at this point you are applying a force F, and this point is at a distance how much? Phi l by 6. That's it. The angular acceleration of the rod. So you have to find the torque divided by moment of inertia.
This is.
So alpha is equal to torque divided by moment of inertia. The torque is what? F into the distance. What is the distance? Phi l by 6. Okay. F into phi l by 6. And moment of inertia of the rod about this point is what? M l square by 3. Correct now?
Yes, sir.
So just take it. So F is given as what? Mg by 2. So Mg by 2 into phi l by 6 into 1 upon ml square, and this 3 will come into the numerator. So 1l is l will go, this m will go, this 3 1s are 3, 2 is a 6 remains. So you get here 5 by 4 G will be alpha units. So
by also.
yes, L also will be there. No, 1 by L. So B will be the option. That's it. Make a drawing and just do it. So I'm introducing you the basics, and we should do this. I mean, I'm doing all these sums, so that you get a sort of a revision for this chapter. Okay, shall I proceed?
Yes, sir.
So, yes.
Will you do this? Try. Should not take so much time for this.
Option B.
So the center of mass is here. So this is the vector W which will be acting down. Weight. Okay. And this distance. This distance will be what? B by 2.
B by 2.
Okay. And he also support this book. So the torque of on the book due to the gravitational force will be what? Will be W B by 2, and it is going to be clockwise. This is clockwise. Okay. Now, if your finger has to oppose this, then the torque applied by the finger on the book, okay, it should also be equal to WB by 2, but it should be in anti-clockwise.
Yes.
Okay, so this is the option, right?
Yes.
But why you took so much time for this? Because
The grip is on the corner.
so you do one thing, you take a book, hold your hand like that and see. You are going to push it like this, no? You are going to hold the book like this and you want to turn it like this. But Earth is turning it like this. So you are going to apply the torque in anti-clockwise direction.
Sir, you are writing that equation about the center of mass of that box.
I am not writing any equation about center of mass. I am writing the equation about this corner only. I am writing it about this corner. I am taking the torque at this point. Torque due to the book at that point and torque due to the hand at that point, they should be equal and opposite. Come on, you don't complicate it, man. It is simple.